All right. In the last section in 13.5, I gave you an area for the pattern of SAS information. Okay, I want to give you one other area formula for a pattern of SSS. Okay, so when you're given a triangle with the pattern of SSS, okay, the equation that you can use to find its area without having to go in and individually find other little pieces of things is to use the following formula. It's called Heron's formula. When you're looking at this formula, the equation is the following. S times S minus A times S minus B times S minus C. Okay, so again, this is called Heron's formula. Okay, and then the pieces of information, S represents the semi-perimeter. Okay, so what fraction of the perimeter do you anticipate that will be? It's one half, right? So it's 1/2 the sum of A plus B plus C. Okay? And so when you look at this, the area itself winds up being the semi-perimeter, half the perimeter, times the difference between each individual side and that semi-perimeter measurement. Okay, so if I gave you something like this, I told you you had sides of 14, 19, and 22, and I asked you to find the area. Usually what you'll see me do always, I'll use, if they don't have it specified where the points are, I'll just use A as the smallest, B as the middle, and C as the longest, but it doesn't matter. All right, so what is the semi-perimeter value for this? Okay, so the semi-perimeter is 27.5. So you're going to multiply that by the difference between that and every individual side, right? And when you take that final calculation, that'll be your total area. So if I took the square root of 27.5 times now you can enter this several different ways. And here's the way that I would look at this is, since I know that this number right here is going to be the same in all of these, rather than type it out every single time, I'm going to just call it x, and then I'm going to assign that a value at the end. So I'm going to say x times the quantity x minus 14 times the quantity x minus 19 times the quantity x minus 22. Okay, so close off my entire expression. And then what can I do to let x represent 27.5? The width key, x equals, and then just type in what we have, 27.5. And so when I do, I get my answer, 131.74 square units for that. Okay. All right. I want you to see if you could find, on a baseball field, how far is the pitcher's mound from first base? So from home to first is 90 feet. You are correct. Okay, so let's draw what we have. All right, so we know that this is 90. Okay, so right, but here is the pitching mound. Is it at a 90-degree angle? No. Does anybody know how far? Nobody knows? All right, so is our answer 60.6? So 60 feet, 6 inches. 60.5, very good. Okay, so, oops. Hold on. Let me come back here. All right, so what is it that we're working in? So when we have this, this measure, do we know anything else about this diagram? The pitcher's mound and first base are cut at what angle? Okay. Do we have enough information to find this distance x? I want you to see if you can solve for that, please. Did anybody get a measure? Which rule are we going to use, or law? So our pattern is SAS, right? Two sides in the included angle. Okay, so we have our law of cosines. Remember, the angle involved and the piece opposite that is always going to be these two outside measurements. So we're going to start with the side opposite. So x squared is equal to the sum of the squares of the other two sides minus twice the product of those two sides, all times the cosine of the angle opposite that. Okay. So is this one that you can use your solver, the solver on your TI to solve? Remember, the one that you can't is you can't use it to solve for unknown angles. So for unknown sides, you can. So we can go ahead and just enter this in our calculators. All right, so once you type in your entire equation, again, I have decimals already, so it'll give me a decimal answer. My answer is 63.7. You guys got something different? What answers did you guys get? If you did get something different, make sure I come by and kind of check just to make sure I see what your calculations look like. Okay. What I would like you guys to do is like you to go ahead and finish working on the homework assignment for the 13.6 work. Okay, or finish 13.5 if you still haven't done that. You can get started on 13.6. Is there anybody who's done with 13.6? So you have the rest of class time to work on those. If you have questions, please feel free to ask. Did I not open it?